Alright guys, here is a video for the lecture, for the notes that we start Unit 5, zero and negative exponents. Now we spend quite a little bit of time in class discovering how do we get negative exponents, where does it come from, and then we also discover how does the zero exponent works. And we spend a lot of time doing examples to discover these ideas of negative exponents and zero exponents. So in this video, I'm not going to go into a lot of depth to discover these rules because we did it in class. I'm just going to show you how to use these rules, okay? So there are 4 rules of exponents that we covered in class. 4 rules of exponent. The first one was from sometime in 7th and 8th grade. You learn one of the I labeled them 1, 2, 3, and 4, but it really doesn't have any specific order. But the first one we wanted to remember is the addition rule, okay? Addition rule of exponents. Maybe it's not the addition because we're really not, actually I should not say addition, it should be the multiplication. The multiplication rule of exponents, okay? So if I'm multiplying 2 numbers and they're exactly the same numbers, okay? So x times x, exactly the same number. If you're thinking x is a 2, so I'm doing 2 times 2 or 3 times 3. So if I'm multiplying exactly the same number and they have 2 different exponents, let's call this one a and let's call this one b. They have 2 different exponents. The rule says if I'm multiplying the same number with 2 different exponents, I can just repeat the base and I can add the exponents. Okay, that is the rule of multiplication. We learned this before in 7th or 8th grade, and we're gonna use it every once in a while. We might have to use this rule in our problems here. Okay, homework. Then the other rule, it might be new to you, but I'm pretty sure we learned in 7th and 8th grade as well, is when you have a number to a certain power and you're dividing by exactly the same number to a different power. So the numbers are the same, okay? If I'm thinking of the number 5, so this is 5 on the top and on the bottom, but the exponents are different. So if I'm dividing 5 to square divided by 5 cubed or something like that. So if I'm dividing these numbers, then we get to subtract the exponent. The top numerator exponent minus the bottom exponent, okay? Now this rule is important because it's from this rule right here that we derived the negative exponents rule, okay? So we have rule number 1, that's multiplication, and then we have rule number 2, which is division. Now rule number 3 is, what happens when I do this division and I get a positive exponent? Well, we know what to do. If I get 5 squared, okay, my final answer is 5 squared, then I know what to do. But what happens when we get a negative exponent? That's what leads us to this case over here. So if I have x to a negative exponent, okay, so whenever I do this division, I end up with a negative exponent. What do I do with that negative exponent? We want to always turn negative exponents into positive exponents. So the way to do that is to write it as a fraction, 1 over x to the a. So I remove it from the numerator here, I write it down here as a denominator and becomes a positive. Now, we went through this in class. I don't like to just tell you this is the rule. We went through in class and we saw why this works, okay? And we went and did a lot of examples to see why this works. So that's the rule we're going to be using a lot. Now, there's also another version of this is, what happens if my negative exponent is on the bottom, negative b? What happened? What do I do with this to turn into a positive exponent? Well, then you get to move that negative exponent, that number to a negative exponent, you get to move it up, and then it becomes x to the positive b, okay? So, and we did some discovery of this in class, all right? So if it's negative on the top, we move it to the bottom. If it's negative on the bottom, we move it to the top. The last rule is the easiest, is what happens when I do the subtraction and I get a 0 exponent? So the 4th rule is the 0 exponent, x to the 0 power. Anything to the 0 power is 1, okay? And we discovered this in class. We played with some numbers here. What happens when I subtracted x, 2 to the 3rd power minus 2 to the 3rd power? Well, we got 0, and anything to the 0 power is 1. We did a lot of exploration in class These are the 4 rules that we're going to be using. Mostly, we are going to be focusing on this the bottom 2 here, okay? The top 2 was to derive the bottom 2. It's for us to explore. We used the top 2, and we came up with the bottom 2 rules. So we are going to be using this all the time because, again, this section here, this objective, is all about 0 and negative exponents. So it's all about these 2 rules right here. So let's use these 2 rules very often here on our homework. So I copied and pasted a few examples, and then I copy and paste a few of your homework questions as well. So here we go. 5 to the 0 power. Well, anything to the 0 power is 1. Okay? Any number that you can think of to the 0 power is 1. 5, I have a positive exponent. I know how to do this. 5 squared is not 5 times 2. Okay? This does not mean that. You need to get that out of your head. This is not a multiplication, it's an exponent. So 5 squared is 5 times 5. Okay? It's 5 times itself twice. The number on the top tells me how many times I'm going to be multiplying 5 times itself. So 5 times 5 is 25. Okay? Now here, I don't have a positive exponent. I have a negative exponent. What do I do when I have a negative exponent? Well, according to our rule that we just did a second ago, it says if I have a negative exponent and I want to become positive exponent, I move it to the denominator. So I write 1 over 5 squared. So there you go. What was negative now becomes positive. Can I go from here? Of course I can. I know what 5 squared is. I just did it a second ago. It's 25. So this is the same as 1 over 25. Okay? All right, let's see now the 0 exponent rule. Let's mix and match around here. So we have 3 times x to the 0 power, which is very, very different than 3x to the 0 power. I put both of them next to each other so you can see how we're going to get 2 different answers here. Here I'm saying 3 times x to the 0 power. The only thing that it is to the 0 power here is the x. The 3 is to the invisible number 1 power. Okay? Every number has an exponent, even if it's an invisible number 1. Okay, so I have 3 to the first power, which is itself. So 3 to the first power is 3. And x to the 0 power, anything to the 0 power is 1. So this is 3 times 1, which is just 3. Okay? So 3 times anything to the 0 power is 1. So 3 times 1 is 3. Now this is saying this entire thing in parentheses to the 0 power. I don't care what you put inside of a parenthesis. If you're putting it to the 0 power, the answer is going to be 1. So anything to the 0 power is 1. And I made sure to include the 3 because I put it in parentheses. Here, we didn't include the 3. We only gave the exponent 0 to the x value. Okay, here, again, the only thing that is to the negative power is the x. If I wanted the 3 to be to the negative 2, I would have put it in parentheses. Okay? That's how mathematics we try to show. If I wanted this to be written in a different way, I'm going to find a little room down here. If I wanted this to be 3x to the negative 2, then we would have gotten a different answer. Okay? But this, I'm going to actually do both examples right here. Okay? So let's do this first one here. It says 3 times x to the negative 2. So the 3 has a positive invisible number 1 exponent. And we like positive exponents. So I'm going to leave the 3 alone because the 3 has a positive exponent, which is just 3. But the x to the negative 2, we have a rule for that. So I grab just this value right here, x to the negative 2, just like I did to the 5 to the negative 2. And I move it down to the denominator. Okay, so x to the negative 2 is going to become x to the positive 2 power. So there is your answer. We are only moving things that has negative exponents. We leave things with positive exponents alone. Okay, so there we go. Now, this is a completely different answer than this one down here. What happens if the 3 and the x is to the negative 2 power? Well, then I can move the entire 3x to the denominator. So this would become 1 over 3x squared. Okay, I move the whole thing down to a denominator position. And there we go. Okay? All right, let's go ahead and keep on practicing because this is a tough concept. So you need to have lots of practice until you start making sense. Again, our goal is to target negative exponents and zero exponents. We want things to be positive exponents. All right, so I always put it equal to and I open a new bar, always, because now I'm going to arrange my items, my numbers, my values one at a time. I have a negative 5. We are not worried about negative 5. Our goal is only negative exponents. That's our goal right here, is negative exponents and zero exponents. That's the two things we are searching for. And every time I find it, I will apply whatever rule I need it. This one is easy because anything to the zero exponent is 1. And negative exponents, I need to move their location. Okay, that's what the rule says. Okay, so negative 5. Well, the exponent of negative 5 is a 1. So we'll leave negative 5 alone. X to the negative 3. Let me grab this item only. X to the negative 3 has a negative exponent. I need to move this guy from the numerator to the denominator. So I'm going to move it down here. X to the positive 3. Okay, I took care of this item. Now let's go take care of the denominator. We have the number 2. The number 2 does not have a negative exponent, so I'm going to leave the number 2 alone down here. The yz in parentheses is saying the yz is to the negative 2 power, so I grab this whole item right here, the yz, and I move its location to the numerator. So the yz, if you please keep it in parentheses exactly how it was, move it to the numerator with a positive exponent. Okay, so this moved up, this guy moved down, and this negative 5 and the 2 stay in the right place. Okay, so that's how you simplify it. Now if you told me, let x be number 2, let y be number 3, and let z be number 1, then now that I have everything in positive exponents, I can plug in any number I want. I can plug in 2 for x over here, I can plug in 3 for y, and I can plug in 1 for z, and I can solve it. Okay, remember order of operations. Parentheses, then exponents. You always have to do the exponents, and then you can multiply, divide, add, or subtract. Okay, so remember, we try to do parentheses first, then exponents before we multiply or divide. Okay? All right. So let's go ahead and take care of one more simplification here. I made it as complicated as possible so you can practice all the rules here. I have a negative x to the positive 2 power. We like positive exponents. We leave this guy alone. This guy is safe. Negative x squared is good. Now y has a negative exponent. Let me circle it. Y has a negative 5 exponent. I'm going to move it down, okay? So y to the positive 5 now. M to the 0 power. Anything to the 0 power is 1. Multiply times 1. And then down here we have 3. Well, 3 is to the positive 1 power, so I'm going to leave it on the bottom right here, 3. The n has a negative 3 power. That's my target. I need to move it up. So n to the positive 3 power. That one is good. And then I have tz, t and z to the 0 power. Let me take care of that. Anything to the 0 power is 1. Okay, now the students in my class were leaving that there. That is not okay to leave it there, okay? Now I can go ahead and clean up. Anything times 1, negative x squared times 1 is negative x squared. So negative x squared times 1 is negative x squared times n cubed is n cubed. Okay, so it's 1 times anything is that thing itself. 3 times y to the 5th times 1 is just 3 times y to the 5th. Okay, so remember, anything times 1 is just itself. Okay, that's why 1 times negative x squared is just negative x squared. All right? And that is your final answer after we simplified and moved things around. As you can see, I tackle one thing at a time. If you are with a positive exponent, I leave it alone right where it is. 3 had a negative exponent, we left it alone right where it was. Okay? Let's do it one more time. Practice from your homework. This comes straight from your first 4 problems in your homework. 37 to the 0 power. Anything to the 0 power equals 1. Okay? I have 3 to the negative 4. Negative exponents, we need to rewrite it with positive exponents. Because 3 to the negative 4 is here on the numerator, we can write it at the denominator as 3 to the 4th power. Now, you can use your calculator and go further. This means 1 over 3 times 3 times 3 times 3. It's not 3 times 4, it's not 12. Okay? This 3 to the 4th power is not 3 times 4. Get that out of your head. We're not doing, these are exponents. Okay? All right. So this is 3 times 3 times 3 times 3, 4 times. Well, we kind of know that, right? 3 times 3 is 9. And then 9 times 3 is 27. And 27 times 3 is 81. So it is 81. Okay? All right. Now let's go over here. We have 5 divided by 5 to the negative 2. Well, let's open our little fraction bar here. Let's go one at a time. Who has a positive exponent? We leave it alone. Whatever has a negative exponent, we need to move it. The 5 has a positive exponent. Then let's leave it alone. The 5 on the bottom has a negative 2 exponent. It needs to go up. So times 5 to the positive 2. Now remember, 5 here has a number 1 exponent. Remember the rule number 1 of exponents I just told you a second ago right here? I said if we have the same numbers, we're multiplying them and we have different exponents, we just add the exponents. So here we go. I have 5 to the 1st times 5 squared. Then we can go ahead and add, it will be 5 to the 3rd power because we add 1 plus 2. Okay, we added this 2 powers. Now, a student of mine asked me, Ms. Myers, do we multiply 5 times 5 is 25? You know that that doesn't work. Okay, we did it in class. This is 5 times 5 times 5. That's what it is. Okay, so it's 5 times 5 is 25. And then 25 times 5 is 125. So you can go further and say this is 125. Okay? Or you can just plug it in your calculator. What is 5 to the 3rd? 125. All right? I was just showing you what this top number means. All right, here we go. Again, a similar example, but different bases. So here we go. Let's open a new fraction bar. Let's take care of who has positive exponent. Any number that's by itself has a positive 1 exponent. So 3 has a positive exponent, we leave it alone. The 6 has a negative exponent, we need to bring it up. Times 6 to the 1st power. Well, I cannot add the exponents here, okay? They're not the same numbers like it was 5 and 5. So this is just 3 times 6, which is 18. All right? All right. Let's go ahead and do a couple more, and that will be our last problems. 11, 12, 13, and 14. So let's take one at a time. I always look at the problem. I set it equal to a new bar because I'm going to move things to the bottom if they are negative. 4 has a positive 1 exponent, we leave it alone. X to the negative 3, we need to move it down, x to the positive 3. Y to the 0 power is just 1. You want to multiply 4 times 1, you're just going to get 4. So there's our final answer. Okay, if you want to multiply times 1, then 4 times 1 is just 4 over x cubed. Okay, there we go. All right, let's do number 12. Open a new bar and then tackle one thing at a time. I don't see any parentheses, so I see 4 different items. I see number 8. 8 that has a positive exponent, so there we go, number 8. M has a negative 2, so I'm going to move it down, m to the positive 2. On the bottom, we have a 4 to the positive 1, then leave it alone. On the bottom, we have n to the negative 1. We move it up. So it's n to the positive 1. Now, we know how to simplify things here. Everything is positive, exponents. We love that. We made everything positive exponents. Now, let's simplify it. 8 divided by 4, that's 2. So we just get a 2. And then n, and then m squared. So we just did this little reduction right here. We could have done it right at the beginning as well. Some students saw that right at the beginning, and they did it at the beginning. That's good. So there's our final answer. You can give me any value now. Say, hey, let n be 1 and let m be 2. Okay, I can plug it in. N equals 1 and m equals 2. I can do the calculation. 2 times n is 1 divided by m now is a 2 squared. Look at that. We can keep on simplifying. After I turn things into positive exponent, you can tell me whatever number you want for m and n, and I can plug it in. 2 times 1 is 2, and 2 squared is 4. And we can just reduce that to 1/2, okay, which equals 1/2. Now, on your homework is not asking to do these things. I'm just showing you that the goal of this is skills. The reason why we're doing this is so you can turn things into positive exponent, and then you can plug anything you want for those variables, and you can solve it. Okay, let's go over here. This was the one that caused a little bit of trouble in class, number 13. Let's work on it together. -6. We're not looking for negative numbers. We're looking for negative exponents. That's what we're looking for, okay? We're looking for negative exponents. That's what we target. So -6 is okay. A has a -2 exponent. We're going to move it down. So a to the positive 2. BC is in parentheses, so BC is a group. It's tied together. You cannot split it. BC squared, stay up here. BC in parentheses squared is safe. So we took care of all these items on the top. Now let's take care of on the bottom. On the bottom we have d to the -4 power. We need to move it upstairs. So d to the 4th power goes back here, and we are done. Okay, we just move things to where it belongs. There we go. Nice and cleaned up. Everything is positive. We love positive exponents. All good. Last one. Equals a brand new bar. Okay. Now we have 5s to the -2. I'm sorry. Let me read this again. I have 5s divided by 6t to the -2 power. There's also a rule of exponent. I don't know if this was covered before, and I'm surprised that this problem is here. But there's a rule of exponent that says each item, the numerator and the denominator, can get its own exponent. So I can say 5s gets the -2 and 6t gets the -2. Okay? I can split the exponent to each of them. It's a rule of exponents. And I'm going to take a side note here just to prove it to you, something simple. If I had, just a side note right here. Side note. If I had 2/3 squared. Okay, how do we square a fraction, Mrs. Myers? Well, it's very simple. The 2 gets to be squared, and the 3 gets to be squared. That is the rule of exponent that I'm trying to explain to you. So the 2 squared would become 4, the 3 squared would become 9. So all you're doing is you're squaring the numerator and you're squaring the denominator. That is exactly what the rule I'm using over here. 5s gets the -2, 6t gets the -2. Now, pretty much, I'm going to move them around because they both have negative exponents. They both need to be moved over. So the 6t needs to go to the top. The 5s needs to go to the bottom. So our final answer would be 6t squared, and on the bottom, 5s squared. Now, I'm not sure if you need to go further. I would be very satisfied with this answer right here because I could give you a value of t could equal 2 and s could equal 1, and who knows, you know, you could just go further by solving that. On the example, on the homework, they're just asking you to take care of it, simplify it. This is good enough. Some students can go further. They say, well, I can use the same exact rule here and say the 6 gets squared and it becomes 36, and the t gets squared and it becomes t squared. Then I can do 5 get squared, which it becomes 25, and the s get squared becomes s squared. And that would be the most simplified answer. I am happy with both because you understand the rule here that we're trying to teach you, which is the negative exponent rule, and you made things positive. It's perfect. Okay? We're not asking you to plug in anything. I'm just saying now that it's positive, you can plug in anything if the problem asks you to plug in. Okay? So I hope this helps you. Practice a lot of practice with negative exponents. We want to turn them into positive exponents. That's our whole goal, okay? We want to turn things into positive exponents. So good luck. Come and ask me for help. Please attend Math Lab. It's a very, very important practice for you to go and be able to ask questions and practice with the teacher. All right, bye.